Good morning, everyone. So today we're going to continue our discussion on multiple linear regression. So quick review, a multiple linear regression is represented by this equation where y is your dependent variable and your x's are your explanatory variables or your independent variables. Y is also known as your outcome variable. Okay, so there are many names given to your y's and your x's, and there are certain assumptions that are uh, followed, or there are certain assumptions as far as solving multiple linear regression is concerned. The method that's used, as I mentioned last time, is ordinary least squares. LEAST, list, ibig sabihin, yung pinakamaliit, the smallest residuals squared. So you compare whatever value you're getting from your model, you compare it with your actual value, the y sub I. Okay. The difference between the actual value and your model value is your residuals, and then you square that. The OLS gives us a model where the squared residuals are at a minimum. And it's a unique solution in the sense that you will not find any other parameters, value of parameters, beta null, beta 1, beta 2, etc., that will give you a lower squared residuals. Okay. So, okay, we said also that the assumptions call for the parameters being linear. So you cannot have the parameters being squared or square root or log or exponentiated. Hindi pwede yun. Okay? That's the first assumption, linearity of the model, linearity of the parameters. Second is that, okay, all right, so this is okay. This is okay where your predictors, x1 squared, log of x1, etc. That's the beauty of OLS, ordinary least squares, or multiple linear regression. The parameters, the explanatory variables could be nonlinear. When I say nonlinear, it could be raised to a certain power. It could be log, log, or you can get the square root of that, or you can also get the reciprocal 1 over x. That's possible. It's okay. So the relationship between your dependent variable and dependent variable should be linear. Okay, kasi it doesn't make sense to use ordinary least squares. Okay, if it doesn't make sense to use multiple linear regression if the relationship between your independent variable and your dependent variable is nonlinear. Suppose if you plot, let's say okay, let me quickly do that. If you plot, for example, your y, this is your y, and this is your x. This is your independent variable, dependent variable. And if they have the plot goes this way, okay, it's more quadratic. So it doesn't make sense to use OLS, ordinary least squares. We'll have to use another model because this definitely will result in a model that will violate the assumptions, in particular this one, which is the third assumption, the homogeneity of residuals variance. When we say homogeneity of the residuals variance, when we plot your residuals, we plot the residuals. For example, this is your residuals E. Let's call it E. And then this is your, let's call this your fitted value, y hat. For a multiple linear regression, y hat. Okay, the residual should behave in such a way that the variance should be constant. Okay, it should have a distribution like this. Constant yung variation, ibig sabihin niya, constant yung variance, ibig sabihin, it behaves randomly across this level of variance. It does not go up like this, okay, neither does it go down like this. So if it behaves this way, then we call it heteroscedastic residuals. The distribution is heteroscedastic, and it means that your model is not sufficient. Okay. Later on, we hope we will be able to reach that, at least do some basic diagnostics of our model. Okay. And we said that let's continue with our. By the way, I think last time, did I mention to you the blue? Kindly confirm, please. Recall, class, did I mention to you blue, the blue model? Yes or no? Mukhang hindi kasi ano, okay, sorry. Thank you, Robin. All right, so let me just quickly explain. I'm sorry I missed this out last time. So what we have certain assumptions, right, for our model, for our multiple linear regression model using OLS, ordinary least squares. And the assumptions are there should be linear relationship between your dependent and independent variables. There should be linearity in the parameters. Okay, the residuals should be homogeneous. Okay, constant variance. Also, the explanatory variables should be not collinear. There should be no multicollinearity. It's not good for the independent variables to be highly correlated. As we said, this will have a problem because it will be difficult to, the word that I use is disentangle. So the independent variables seek to explain your dependent variable. If they're correlated, if they're highly correlated, then it will be difficult to determine which is explaining which part of the variability of your dependent variable is being explained by independent variable 1 or independent variable 2. Since they are highly correlated, there will be what we call shared variance with the outcome variable. Okay, and we will test this. And then, of course, the residual error term should be independent. Okay, this is related to the homoscedasticity. Because if they're independent, then they will behave in such a way that there will be a trend. No? Kung independent sila, siguro pataas yung the residuals will have a trend. They will be going up, or they will be fanning out or fanning in. Okay, there will be a funneling effect, etc. So this number 5 is related to number 3. And lastly, normality of residuals. The residuals should be normally distributed. Although this one is, let's say this is the weakest, weak, W-E-A-K, weakest of the assumptions. Okay, and if you have a large sample size, okay, this might not be relevant in normality and residuals. Now, when all of these assumptions are met, then we are able to generate what we call the blue model. Okay, the blue, B-L-U-E, blue. What does blue mean? Blue means best linear unbiased estimators. Yun ang ibig sabihin ng blue. No? And that's what we seek. We seek that our model be the best. Okay, the best because it gives us the least residuals, no? Squared residuals. Linear, of course, we explained this already. Best linear unbiased. Okay, unbiased. We'll explain what unbiased means as we go along. Unbiased estimator. Okay, our parameters are the best linear unbiased estimator. Now, when there is a violation of homoscedasticity, i.e. your residuals are heteroscedastic, then the model is still linear, the model is still unbiased, but it's no longer the best. Okay, hindi na siya best. Pag na-violate yung heteroscedasticity. No? Which means that there's another model, okay, that will give us the lower residual squared. Okay, so that's why after we generate a model, we have to test. We have to look at the assumptions and determine if there are violations or not. If there are violations, then we have to address that, which will be part of the next lessons. But for today, I think we will be able to complete yung multiple linear regression natin. Okay. All right. So let's go here. Let's first load our packages, tidyverse, psych, pastex, OLS, stargazer. And then my data is not yet loaded here. Okay, so make sure that your data is loaded. If you open the project itself, then the file is here in wage CSV natin. So let me open this. Read R comes from the package. Yeah, this is the package read R. Actually, I don't need to write this because I already loaded tidyverse, and tidyverse also includes read R. But nevertheless, I'll just put it here so that we know that this function read underscore CSV comes from the package read R. The advantage of having a project is that when you load a particular data set, okay, you just write this. You don't need to write the where that data set is, the file location of that data set, because it's already loaded in your project. All right, and this data has column names, has variable names. So let's run this. Okay, so it will generate a window here, there. Okay, so last time we said that the variable of interest is hourly wage, and we would like to regress hourly wage on okay, on these parameters: education, experience, tenure, etc. Last time we started with a simple linear regression. Let's have a quick review of that. Okay. Right. So it's always important to look at your data set first. In your case studies, in the cases, in the requirements of this course, you will of course need to look at the data. There are several EDA packages. EDA stands for, let me write that, EDA stands for exploratory data analysis. So even before you start doing, for example, a regression, you have to look at your data and explain your data. Okay. All right. So quickly, we know that the wage data set, let me just run the structure. All right. So this is a data frame. Okay. It's actually a special table. It's a table, the data frame, and it consists of these variables: education, which is numeric, and you have here 3 character variables, and there are 5 numeric. 1 is your dependent variable, hourly wage, and 4 are your 4 numeric explanatory variables and character variables. Now, when we use character variables as predictors, okay, they have the attribute of being factors, and we said factors are classifiers. Kasi hindi naman pwedeng it will not benefit us if we're using character variables which we cannot use as characters, categories. For example, kunyari, meron tayong field na address. No? So we have 1,000 respondents, address. Tapos yung mga address na yun, iba-iba. No? Ibang number, ibang location, etc. So how will that benefit the model if we're going to use it as a regressor? Okay, walang gamit yun. All of them are unique. Tapos we cannot possibly use that as an independent variable. However, if for example my field na city, city where that respondent comes from, so either Manila, Quezon City, etc., then pwede yun. That character variable can be construed, can be treated as a factor siya, no? Tapos pwede siya maging part of the regression model kasi we can now make differentiation between those from Manila or those from Quezon City as regards the variable of interest. Kunyari ito, meron tayong city dito. No? So saan nanggaling ng city yung respondent dito? So since we're looking at the hourly wage, may kinalaman ba? Does the city of residence have something to do with the hourly wage in this company, or in general, the hourly wage? So we can look at that. So very important to understand the concept of the role of a character variable in a multiple linear regression. As we said, we do not use a character variable that cannot be treated as a factor. Okay? These variables, si race, white and non-white to, si gender, female and male, civil status, single and married. This can be used as categories. No? So we can see that if there's any difference between the hourly wage of a white person and a non-white, female and a non-female, single and a married, okay, in terms of hourly wage. Okay. All right. So describe from the site package is also gives us certain measurements. Okay, in this case, what will be given are, okay, sandali ah. Have here the 7 variables. Okay, so andito yung mga descriptive statistics, no? Yung count, average, standard deviation, median, trimmed median, etc. Okay, quite a lot here. Maybe we don't need everything, so we should be very choosy with our choice of descriptive statistics, and then explain, of course. Okay. Okay, so let's go to our, last time. Okay, GG-Ally is another package, and let's just run this. This is a very good way to show the relationship between your variables. And we would want the independent variable to be highly correlated with the dependent variable, but not the independent variable with themselves. Okay, so we can see here, all right. So we have here a plot of all your variables. Okay, education, experience, tenure, and these are your factors. Then you can see here the number here represents the correlation between education here and experience. So it's negative 0.3. It's statistically significant. So in a sense, this is, well, there is a weak correlation here, or moderately weak correlation. And that might not be good because we don't want the independent variables to be correlated to each other. What we want is also this one. This is not even statistically significant. So practically the correlation between tenure and education is 0. Now we're also very much interested in this one, the correlation of hourly wage with the predictors. And you can see, of course, there will only be correlation for with the dependent variable and the numerical variables. So here we find that education is moderately correlated with hourly wage, statistically significant. That's here the 3 asterisk here. Also experience, this is quite a weak correlation, 0.11 lang. Si tenure naman with hourly wage, okay, moderate din yung correlation. Si number of dependents, yan, wala siyang correlation with the hourly wage. So we can make a guess, a bold guess, that when we run multiple linear regression, maybe hindi magiging si number of dependents, hindi siya magiging statistically significant. Kasi walang correlation no? Walang correlation si hourly wage at si number of dependents. All right. So last time, what we did was to create this model. Okay, we called it model 1, and this model is a simple linear regression where we regress hourly wage tilde on education. Okay, so this is how we write the model, and we identify the data is equal to wage. Then we create this object mod1, and then I put it under summary, inside summary, so that it will automatically generate the result of this model. Okay, so this is where we stopped last time. Okay, we interpreted this. I'm not going to interpret this again because we're going to go to a multiple linear regression, and that's what we're going to interpret now. All right. So let's now go to the next one. Okay. May I ask, class, if you have this, itong mga matrix representation na to? Do you have it in your file?
Yes, sir.
Okay. Now, I'm going to skip this. I have a recording about this. I'm going to post it na lang sa Canvas. Kasi this explains how the model is solved using matrix algebra. Okay? Dali. Saan yung ano natin, yung equation ng matrices? Wait. Okay, is it here? Yeah, okay. So this is the matrix equation to solve for your beta, your parameters. You can see here beta hat. So this is the predicted value of your beta is equal to x transpose x inverse x transpose y. Okay, this is a very popular matrix equation for solving the parameters. So this is what Excel R does. Okay, yung engine itong R, ito yung ginagawa. This is what it does when it generates or computes for the data. So the code is already here. In fact, do you have this, class? Do you have this code also? Hello?
Yung solve the x.
Yeah, this one. This one. Yung n row, meron na. So actually, this is the solution. Okay, so I won't be discussing that now, but I'll share with you a video about my discussion of this particular solution. Okay, so but just be aware that how does R or how does any statistical software solve for the parameters? It's this one. It comes from matrix algebra, and here is a code, okay, to solve that. Ito yun, no? Solve is your matrix multiplication. This is your transpose, T of x, okay, and then, solve is your inverse. Yan. Ito minultiply natin, ito yung matrix multiplication. So x transpose x, so that's transpose of x multiplied by x. And then this inverse is this one, this solve. And then we have another matrix multiplication here. So ito times ulit natin sa x transpose. So multiply that by transpose of x and then multiply that by y. Okay? Of course, define natin kung ano yung y, kung ano yung x, kung ano yung x transpose. All right. So let me skip that and just share with you another discussion on that. Okay. So let's go here now. Okay. Okay, multiple regression. Dito tayo. Check correlation. We have already done that. So Control Alt I. Let's now create our second model. All right. So our model 2, let me call it model 2 Alt minus is equal to linear model. Okay. Hourly wage regressed on. Okay. So we'll be needing the names of, let me just get the names here. Names of wage. Okay, so let me just copy this so that delete na lang ako, Control C. All right, Control V. Control F. Sorry, shortcut ko lang kasi para mabilis. Quotes, tanggalin, no? All. So tinanggal ko yung quotes. Okay, and then I'll just add plus. Theta is equal to average. Let me just give a space, some space here para mas kita natin. Okay, and then kindly chat if you have written the equation. Import yung wage. Okay. Richard, could you kindly please, yeah,
Okay, sir.
kindly, dali. Let me just, saan na yung ano ko? Yung share. Okay. Richard, could you kindly share your screen, please?
Okay na, sir.
Okay, wage with R, CSV, column names, true. Wala pa yung ano mo, yung wage data. Tingnan mo
Yun nga,
sa
sir.
lower right. Okay. Sige, i-share ko yung wage data set dito sa chat box, no? Tapos
Okay.
i-ano mo siya and then i-load mo dun sa project mo sa project folder, no?
Okay, sir.
Sige.
Thank you.
Okay, sige. Let me get that file. Okay, na-share ko na yung ano. Richard, kindly
Okay,
download that.
sir. Thank you.
Sige. Tapos, i-ano mo, sabihin mo kung okay na.
Copy, sir.
Sige. Okay, thank you for that, Richard. You might have some questions and then pag i-chat nyo, baka hindi ko kagad makita. No? So, it will be good for us, for you to unmute yourself na lang. No? Para, kasi baka mahaba na yung dinidiscuss ko tapos hindi kinakakahabol. No? All right. So, are you okay, Richard?
Yes, okay na, sir.
Okay na, sige. Good. Thank you.
Thank
All right. Now here, we're doing multiple regression now. Multiple because we have several regressors, we have several explanatory variables. The first example we had is a simple linear regression. And from what we learned about the output, the model can only explain 16% of the variation of the dependent variable. Ibig sabihin, 16% lang. Ito, 16% lang yung adjusted R-squared.
Ay, sir,
Okay.
hindi yata kayo naka-share.
Ay, di ba naka-share? Sorry. Thank you. Okay. Yan. All right. So as I was saying, yung first model natin, yung education lang yung is the regressor. Our adjusted R squared is only 16.32%, which means around 83 or 84% cannot be explained by education. So that's why it's important to have other, of course, relevant parameters in explaining your variable of interest, in explaining your, in this case, hourly wage. No? So I can put here summary, okay, so that it will automatically already print the output. All right, let's run this. Wait. Hourly wage. Ay, mali yung ano ko. Sorry. Mali yung data ko. Yung hourly wage. Okay, here we go. All right. So kindly chat, please, if you were able to generate the model. Okay, thank you, Alvin. Let's wait for the others.
Sir, pwedeng pataas ulit.
Sorry.
Sige.
Here.
Thank you.
Okay. Okay, thank you. How about the others? Okay, good. Right. Any questions? I think everyone got it. Unless, please feel free to ask questions. We don't want to leave anybody behind. Okay. Okay, good. No questions. All right. Now, this model is actually the same as this one. So if you're going to use all the variables in your data, you can just use this dot. Okay. So this represents all the variables in the data, of course, except for the hourly wage. If I run this, okay, let me just see. So this is negative 3.389.57. Let's see if we get the same answer. If I run this. All right, so exactly the same. Okay. So you might be surprised to see some models like this. This just simply means that we include all the explanatory variables. So let me just comment that out. All right. So let's interpret this now very quickly. So this is the formula that we use. You have the residuals, minimum, maximum. Then we have here. Then we have here. Mark, mute lang muna kita. Nag-echo kasi. Okay. So we have here the coefficients. No? These are the parameters. Okay, let's take a look at this, and we have to know how to interpret this. It's not enough for us to generate this output. One of the discipline that we need to have is to be able to explain what these parameters are. So let's start with education. Education is statistically significant at 0.001. Tatlong stars yan dito sa R. It refers to this one here. 3 stars. So which means that our p-value is less than 0.001. So this is statistically significant. Sabi natin, the null hypothesis in this tests. Let me write that. So the null hypothesis here is that education H null, okay, is that, let's call that beta 1. Yung beta 0 natin intercept. Beta 1 is equal to 0. Okay, so we're testing the hypothesis that the parameter for education is equal to 0. Okay, and here we reject that null hypothesis. Okay, we reject that null hypothesis based on the p-value. We said that if the p is low, the null must go. Okay, so this one goes, we reject this. So there's strong statistical reason to believe that your parameter for education is a value that's non-zero. In fact, the average is 0.57. Okay, and how do we interpret this? This means that for every 1 year increase, 1 year increase in education, there's a corresponding $0.57 increase in hourly wage. That's our dependent variable, diba? Hourly wage. There's a corresponding $0.57 in hourly wage, but we have to put this ceteris paribus. Mahirap sumulit sa mouse na to. Ceteris, sorry, and I won't write there anymore. Ceteris paribus, C-E-T-E, type ko na lang. No? Hirapan pa ako. Tatanggalin ko na naman to. Ceteris paribus. What does that mean? Yung ceteris paribus, it means, class, that all things being the same. Ibig sabihin, we only increase education by 1 year. Experience, tenure, and the other variables will not be changed. We will not increase them. So that's what we mean by all things being the same. It's only education that we're going to increase, and the marginal effect of education on hourly wage is 0.57. So hourly wage will increase by $0.57 if we increase education by 1 year. So we're not going to increase education, experience, tenure, etc. Okay. So let's go to the other variables. Itong tenure. Itong experience, 0.02. Notice that the p-value is 0.07 and it has 1 dot here. So this means that it is only significant at 0.1, 10%. However, even before we start with the regression model, we already make certain assumptions. Yung assumption natin that our alpha, our level of significance, is 0.05. Okay, so we stick to this. Hindi natin pwedeng sabihin na just because this is 0.1, ay gawin na lang natin yung, let's make our alpha as 0.10. Okay, so that will be cheating, no? That will be cheating. Kasi ang standard natin 0.05. Okay, of course, in the text, in the discussion, we can mention that experience is significant only at the 10% level of significance. Okay, so experience is not statistically significant, which means that it's possible that this value is equal to 0. Okay, random chance lang naging 0.02. Ito. Okay, and then how about tenure? Tenure is statistically significant at the 0.001 level, and its value is 0.138. And do you notice, didn't we a while ago said that education and tenure, did we mention that they have high correlation with our hourly wage? And it does show here, no? That they're significant predictors of hourly wage. They have high correlation with hourly wage. Si experience, di ba, mababa? Diba? Oh, yeah. Sige, mamaya na lang. All right. So number of dependents is not significant. Okay, the p-value is very high, 0.17. So, and in fact, I mentioned a while ago that number dependents and your hourly wage are not correlated. And it showed here that number dependents is not a significant predictor of hourly wage. Okay, now let's focus on these variables. Let me clear this. Now, why is it that I'm having here race white, okay, and then gender male, but race, our variable is race, gender, and civil status. Why is it that white here is appended or affixed? Male here is affixed and single here is affixed. What happened here? Isn't it that our parameters, our variables are race, gender, and civil status? So why is it now I'm now having race white? Okay. Now the answer here lies in this one, in the fact that these are categorical variables and R automatically, okay, converts them into factors. Okay. Before, there was a time when when hindi tatanggapin ni R yung R will not accept that kind of a model. Yung LM and then hourly wage regressed on a character variable. Kailangan convert muna natin si race, si gender, at saka si civil status as a factor. So that it's very easy to do that in R. No? So let me just illustrate. If there's a need for you to convert that character variable into a factor, you just do it this way: wage, dollar. If I write wage and then dollar, it will automatically bring me what's inside wage. So here raise, alt minus, okay, and then I just use the as that factor function. So this is coming from the base R package. As that factor, and then Control C, Control D. Okay, so I'm just telling R to convert the race variable into a factor. As underscore factor. Di ba as that? Pinalitan na. As underscore factor na. All right, so if I run this, Control Enter, and I can now see if I get the structure, or let's see, class of wage, race, hindi, class nito, hindi, factor na siya. No? All right, so if I get the structure also of wage, ang structure na ni wage, as ni race pala, I mean, okay, si race factor na, no? Si gender, character pa rin. And si civil status. Kasi we did not change it naman. Okay. All right. So, before, I had to do this. No? Kasi if I run this regression, it will not run because the three variables, this race, gender, and civil status are all characters. But now R automatically converts them into factors. Now let's discuss what happened. Why did it become race white? Okay, take a look at the variable race. There are two levels here. So race has two levels. You have alphabetically what appears first is non-white. Alphabetically, non-white, and then the other is white. Okay, so you only have two levels for race. So what will R automatically do? R will convert this automatically into what we call dummy variables. When you say dummy variables, it will replace dummy variables. It will replace it with values of 0 and 1. 0 and 1. Okay, so para magiging, it becomes like a numerical variable. So since it's now like a numerical variable, it can now be used as a predictor. Okay, so what is R doing here? The default is it will assign a value 0 to the variable, to the value, to the level that appears first. And then it will assign value 1 to the level that appears next. Okay, so what's happening here is that, and what R does is that it will attach the one with the one value to your variable. So it will make it raise white, which means that all the whites here are 1. Pag may non-white, it's 0. Okay, and what's the rule? How many dummy variables will be introduced? The number of the dummy variables will be equal to the number of levels minus 1. The number of levels is the number of types. For example, sa race, we have non-white at saka white. So we have 2 levels here. So the number of dummy variables will be, okay, number of dummy variables will be number of levels, which is 2 minus 1. Therefore, only 1 dummy variable. Kaya nakita lang natin race tapos white. Okay, you only have 1 dummy variable. Same for gender. See, gender, you have only female and male. So what happens here is that, again, automatically R will assign 0 to the value, to the level that appears first alphabetically. So 0 plus 0. 0. 1. 1. 1. 1. And R, by default, call this gender male. Kasi yung 1, yung male. Okay? Also civil status. Married, since this appears first alphabetically, M siya, versus S single. So this has a value of 0. This has a value of 1. So all singles here will have a value of 1. All marrieds will have a value of 0. Okay, that's what we mean by converting it into dummy variables. Okay, so they are now technically quantitative. So makakapag-compute na dito. Computation can be done because these are now numerical in a sense. Okay, all right. Now let me just go back here, levels minus 1. Suppose you have a variable, say year level. This is year level. Let me just call it YL, year level. And you have, let's say 4. You have frosh, then you have your sophomore, you have your senior, and you have, junior, and then you have your sophomore, senior. Okay. The question is, how many dummy variables will be generated here? Anyone, please? How many? Yes, correct, 3. Bakit 3? Kasi, di ba, levels minus 1. So what will happen? Alphabetically, which level will appear first? You have frosh, you have sophomore, you have junior, and then you have senior. Since frosh appears first alphabetically, then this will take on the value of 0. The rest will be 1. Okay. So how do we now capture this? Kunyari, meron ako ditong, let me just give an example. Kunyari, frosh, I have sophomore, I have frosh again, I have junior, I have sophomore again, I have frosh, I have senior, I have senior. Okay? Unahin muna natin si sophomore. Sophomore, I have junior again here. Huli ko na si frosh. All right. So I have this variable, YL. It's a character variable, but we know that this can be categorized. We can use this as a factor so that we can use this in the regression to see the differences between a junior, sophomore, senior, etc. So that's why we can dummify this. Okay, so in your code, you can make this as underscore factor. But if you do not, automatically R will do that. And we said that there will be three variables that will be introduced, three dummy variables. Okay, what are these variables? So this variable, YL, year level, will be replaced by three. The first one will be YL, let's call it YLSO, YLSO sophomore. Okay, then we have YL junior, and then let's erase this. And then at ayaw maano itong erase. Draw. Yan, okay na. Dali, ha? X ko muna. Okay. Annotate again. All right. So we have year level and then senior. Ang hirap. Dapat nag-work yung digital pad ko kasi hindi. Okay, so this one, so this will be replaced. Itong year level na to, it will be replaced by three dummy variables. And how will this look like? So this is sophomore, right? So sophomore will have a value of 1, junior 0, and senior 0. Because this is sophomore. So this level will be represented by this. So it will take three dummy variables to show who a sophomore is. Junior has to be 0 and senior has to be 0. And we know that Frosh is 0 because that's the default. No? It's okay, Mary. Attendance mamaya na lang, ha? It's okay. All right. So here, sophomore. Okay, ganun din, no? 1, 0, 0. Okay, how about junior? Junior will now be 0, 1, 0. Right? Junior 0, 1, 0. Senior here will be 0, 0, 1. And Frosh will be 0, 0, 0. There. Okay, so we were able to capture all the levels using three dummy variables. Now, why is it that we just why not just include YL and Frosh? No? Para magiging 0, 0, 0, 1 to. Diba? So why not just use 4 dummy variables so that si Frosh it will have its own dummy variable here. Okay, the reason for that is what we call, this will lead us to what we call a dummy variable trap. Sorry, trap, dummy variable trap, and it will lead us to what we call multi-collinearity. Okay, I'll explain this as we go along. Suffice it to say, class, that we do not do this because we will have an issue of multi-collinearity. Yeah. Richard, may minention si Richard na one-hot encoding. Could you explain that, Richard?
Parang siyang way, sir, na i-convert yung mga categorical variable into something that can be read by computers, again, ng ones and zeros.
That's correct. Oh, that's correct. I don't know if we will have some time to discuss machine learning. Siguro, towards the end, magbibigay ako ng ng machine learning example on regression, and then we will be using one-hot encoding. You're correct, no? Yung one-hot encoding na yan. All right. So suffice it to say, class, that if you have 4 levels of your factor variables, then R will automatically use YL minus 1, the level minus 1. Okay, that's why here, hindi ko natin drawings natin. In our model, you can see here that C raised 2 levels yan. So it only introduced 1 dummy variable. Okay? And in-append niya, in-attach niya yung dummy variable na, yung level na may value na 1. Okay, so si white yung 1, si non-white yung 0. Here, gender is 1, male is 1, female is 0. And in this case, single is 1, married is 0. What was the rule used by R? Alphabetical lang. Is it possible to assign otherwise? Oo, pwede. No? Pwede, madali lang yun. But let me not discuss that now. Ang importante sa atin yung interpretation nito. All right, let's go here. Race white is not significant. No? Okay, ibig sabihin si race does not contribute to the explanation of hourly wage. Walang kinalaman si race kay hourly wage. But let's take a look at this gender. Okay, and it's statistically significant. And what does this mean? 1.76. Let me just approximate it to $1.76. This means that on the average, okay, so hindi na natin no? We do not interpret it as for 1 unit increase in gender. There's no such thing. No? On the average, male respondents receive $1.76 more than their female respondents, ceteris paribus, in terms of hourly wage. No? All right, let me repeat that. On the average, male respondents receive $1.76 more of hourly wage compared to their female counterparts, ceteris paribus. Okay? So yun ang ibig sabihin nun. So the interpretation of a factor will always be in relation to the reference variable or the benchmark variable. Yung female dun, we call it reference variable or benchmark variable. Precisely because when we interpret the parameter here, it will be interpreted in relation, in reference, as a benchmark to that other level, which is female. If this was significant, itong race white na to, assuming this is significant, then we say that on the average, white people receive around 11 centavos, $0.11 more than their non-white counterparts, ceteris paribus. Ganon din si civil status. On the average, single respondents receive $0.46 less, kasi negative to, no? Less than their married counterparts, ceteris paribus. Now, had we reverted, had we changed the benchmark, kasi pwede yun, di ba? Ang benchmark natin dito pwedeng non-white. The answer would have been just negative 1.0996. Pareho lang. Opposite lang yung sign. So ang interpretation natin nun, non-white people receive $0.11 less than their white counterparts on the average. All right, that would have been the result. Okay. All right, so we can see here that number of dependents is not a significant predictor. Race is not a significant predictor. Civil status is not a significant predictor. Experience also is not a significant predictor. Kasi it's significant at 0.10, but that's not our alpha. Our alpha is 0.05. Now let's take a look at this overall goodness of fit test. So this is the overall goodness of fit test. Now, saan ang galing itong standard error? No? By the way, later on we will be looking at these standard errors. Okay, because this has something to do with the assumption of heteroskedasticity. Homoskedasticity, I mean. All right, we have here 518. How did we get this degree of freedom 2? Because there are 2 degrees of freedom here. Degree of freedom 1, degree of freedom 2. And this was very important before, when in order to solve for the p-value, we looked at f-stat tables. Okay, kasi kailangan natin yung f-stat value and then yung degree of freedom 1, degree of freedom 2 to determine the p-value. Okay, degree of freedom 1 here refers to the number of predictors, diba? 7 all in all. Degree of freedom 2 is your n minus k minus 1. Okay, the number of the size of the natin, no? N row ng vector natin, n row ni wage. Okay, 526 observations minus k, which is the number of predictors, which is 7, and minus 1. So that's 526 minus 8. So you have here 518 yung degree of freedom natin, degree of freedom number 2. All right, but what's important here is this one, the p-value. So the null hypothesis here, as we mentioned before, is that ano siya, no, combined siya na ano. That's why this is also called combined test. Null hypothesis is beta null is equal to beta 1 is equal to beta 2 is equal to beta 3 is equal to beta 7, which is equal to 0. So lahat yon, class, lahat siya equal to 0. Therefore, we reject that null hypothesis. P-value is practically, this is significant at 0.001. Okay, less than 0.001 siya. Okay. So we reject the null hypothesis that all of our parameters are all equal to 0. There's strong statistical reason to believe that at least one of them is non-zero, as shown here. No? There's an individual t-test natin sa kanila. And also, this one. This one. Multiple r squared and adjusted r squared. So what does this tell us? Yung first model natin, ang multiple r squared lang niya is, balikan natin yung first model natin. Okay, this one. Yung simple linear regression, 16% lang, 16.48. Tapos 16.32 yung adjusted r squared. Okay, for this one, ang multiple r squared natin, 37%. So there was a big jump. Adjusted r squared natin, 36.19. Which means that our model is now able to explain 36% of the variability of your dependent variable RU range, as compared to our simple linear regression model natin na 16% lang. Now, let's take some time, class, to compute for your, okay. So I'm going to copy this. I'm not sure if we discussed this last time. I don't think so, but okay. This one. Okay. Saan na si... Wala. Okay, sige. Let's define... Okay. Okay. It's important for us to understand this. So let's first define... Okay, may question yata. We pause for a while. Okay. Good morning, Blaze. Okay, let's define control alt I. For those of you who came in late, don't worry kasi ano naman, naka-record naman yung part that you missed. No? So ipopost ko to. No? Okay, we have what we call SST. Anyone familiar with this expression, SST? Sum of the squares total? Yeah, oo. Sorry din kung kasi late ko na rin na post yung message. No? Apologies for that. Okay, anyone who has met this term, kasi di-discuss natin very quickly, SST, SSR, and SST. So that you know where these values are coming from. Pati yung adjusted R squared. Adjusted R squared. R squared. Okay, anyone? What's SST? So this is called the sum of the squares total. Okay, ba't ko nga pala binigyan ng ganyan? Okay, mali ito. So, we're natin, all right? So, what's the sum of the squares total? In this case, what we want is to get the squares na naman, no? We will have to square the difference between, so this is your, ang difference ito, y sub I minus y min. Okay? What's the meaning of this? Kasi gusto natin, we're coming up with a model not using your regressors. not using any of your independent variables here. So hindi natin gagamitin si education, experience, tenure, si race, si gender, etc. So ano gagamitin natin? Si y lang, yung values lang niya. We're going to use the values of y by getting the average. Okay? So we will call it SST. Okay, is equal to, okay, may y sub I na ba tayo? Maglagay ulit ako dito ha. Control I. Okay, I'll call y sub I, yi. It's your, from the wage, hourly wage. Okay? So nag-create ako ng object, yi. This is your hourly wage values, yung actual values. So, i-run natin to. So, may y sub I na ba ako? Let me check. Yeah, meron na, no? I now have y sub I. All right. So, we will now create this SST, sum of the squares of your total, which is equal to y sub I, okay, minus mean ng average ng y sub I, no? And then we square it. Okay, so you can see here the sum of the squares of the total is equal to the difference between your actual value minus the average. So each of the values of your y sub I, your hourly wage, will be subtracted from the mean. Kukunin yung difference nun, tapos i-square natin. So if I run this, okay, print na natin automatically. All right. And then, sorry kulang ko dito. Okay, after square natin, isa-sum natin siya. Sum. Dapat yung sum niya. Kaya nga, sum of the squares. So dapat it should be only one number. Control Enter. May mali ako. Ano yung mali ko? Mali nga. Yan. Alright, so this is the total. Malaki siya, no? Y sub I minus mean Y sub I. Yan. Para masyadong malaki. Negative 0.26. Parang may mali. Tama ba to? Wait na. Y sub I minus average Y sub I. Okay. Sum. And then what I did is square ko siya. In-square ko siya. Tapos so may kulang ako dito. Ito yung kulang ko. Sum. And then may kulang ako dito. Okay, let me see. Yan, tama na siguro to. All right, yeah. That looks more reasonable. Hindi ko napasok siya sa loob ng sum. No? If you're confused with this, pwede natin tanggalin to. And then just print SST. Para mabawasan na yung mga parentheses kasi minsan nakakaano yung parentheses. All right. So that's our sum of the squares of the total. Now what is SST? Si SST naman is sum of the squares of the regression. Okay. So what are we measuring here? Di ba nag-model tayo, nag-model 5 tayo? Okay? So what we're going to do here is, it's equal to, we will get the difference between yung y hat natin, okay, which is your predicted value, minus yung y mean. Okay? So, based on the original model natin, yung average lang, nag-generate tayo ng y hat, ng mga predicted values using the regression model. Yung difference niya, what we're going to do is, square natin ulit to. Tapos, dito ako nagkamali kanina, kaya isusulat ko na dito. Isa-sum natin. Sum. So, yung predicted value minus the average value squared, and then i-add natin sila lahat, that's what you get for your SSR. So, let's do this. May y hat na ba tayo? Makukuha natin yung y hat ng SST, SSR. So, natin makukuha si y hat. Let me copy this. Y hat, yung predicted value will be coming from our model, model 5, and then dollar, model ano ba? Model 2. Sorry, model 2. And then, sandali. Maybe we better mag-generate na lang tayo ng ano dito. Y hat is, okay. Di ba, class, si ano natin, si model 2. Ano laman ni model 2? Ayan, di ba? Ito. Ito yung fitted values. These are your predicted values. Diba? So we can tap this, we can use this. So here I'm saying si y hat is, it's coming from my model 2 and then dollar fitted values. There. Okay? So I generated this object y hat and it's equal to, coming from model yung fitted values. Okay, control enter. So I now have this y hat, which is also a vector of the predicted values. So now, dito, it's my y hat minus yung average natin, y mean. Okay, mali ako dito. Dapat mean of y din to. No? Mas maganda sana kung nag-create na lang ako dito ng y mean, which is the mean of wage, pwede rin wage, hourly wage. Okay? So that's the average of hourly wage. Control enter. So we can now use that here also. Pwede natin itong palitan ng y mean na lang para mas konti lang yung mga parentheses. And then here, y hat, predicted values minus the average squared, and then sum. And then ipiprint natin siya, SSR. After this, I'll pause for a while, class, kasi baka I might be going too fast. So may SSR tayo. Okay, sige. Let me pause for a while and comment out ko muna to. So I'll run this. Okay, so I now have our SSC and SSR. Sum of the squares of your total and sum of the squares of your regression. Okay, let me pause. And then kindly chat, please, if you were able to get it. Okay, my bad. All right, so let me repeat what we did here. Okay, we are computing for the SST, sum of the squares of the total. Okay, how do we compute for this? We just compare the actual values of hourly wage with the average. So here we're saying we're not going to use any of the regressors. Okay, our model, our base model will just be to get the average. So that's our predicted value. That's the average. And the difference between what were the actual values of your hourly wage and the base model, which is just the average, we get the difference and then we square it and then we sum it. It's called your sum of the squares total. Okay. All right, next. We used a model. We used model 2, which is using education rates, etc., to generate a fitted model. And the fitted model, our predicted model, is coming from model 2 dollar fitted value. So these are our predicted values. So we get the difference between the predicted value y hat minus the average. Okay. So in other words, we're not using the average anymore as our model. We're using y hat. So let's get the difference between the average and the predicted value, and then square it, and then get the sum. All right. And what we get is the sum of your squares regression, or that's your sum of the squares explained. So we were able to explain 2652 out of the 7160 variance. Okay, measure of variance, we were able to explain 2652. And of course, we know that the unexplained will just be the difference of this. Okay, so let's just write here also SST minus SSR. Okay, let's compare this. And I'm going to run all of this. All right. So here we can see that SST is 7160. What's explained 2652 is the regression, sum of the squares of regression. Of course, if this is higher, then that would be better, because our predictors were able to explain more the total variance. And then this is your SSE, your SS, sum of the squares of your errors, which is just the same as your SST minus SSR. Okay, let's expand this a bit. Okay, here we have now your R squared. R squared is simply what can be explained divided by the total variance. All right, so SSR divided by SST. So that's now our adjusted our R squared. If I run everything again, right? So that's 37.04. Okay, so this is our, okay, let's give this a name, R squared. Or maybe let me call it R2. R2. Run again. So our R2 is the difference, and then the ratio is, sorry, happened here, SSE, this one. Sorry, mali. Sorry. This is not R squared. This is R squared. It's a proportion of sum of the squares residual regression divided by total. Okay, so this is ano nangyari sa R2 natin? At hindi nag-print ng R2? Ah, sorry. Hindi ko kasi sinama si R2. Okay, sorry about that. All right, so this should print now. Ayaw pa rin. What happened here? SSR over SST, and then print R2. Okay. Anyway, I'll just print this 37%. And you can see this here in our model, diba? Ito yun. So this is the multiple R squared. Okay. And lastly is your adjusted R squared. How is this computed, class? The adjusted R squared. So let me just give the formula medyo mahaba. No? It's 1 minus R squared times n minus 1 divided by n minus k minus 1. All right. So this is the computation for your adjusted R squared. Let's call it IDJ R2. R2 na lang. No? So maganda siguro to R squared. All right. And it's equal to, let's do this, 1 minus quantity 1. I-run ko muna tong ano ha. Sorry. Let me run first R2. 1 minus R squared. Okay. Times, what's our N? N is our number of observations, diba? N row ng wage minus 1. Okay. Divided by N row of the wage, that's N minus K. What's K? This is the number of predictors. Dapat 7 lang kukunin natin, ano? So that's okay. I'm almost tempted to write 7 here, pero it's not good practice, class. No? So how do we get the number of anyone? How do we get the number of K, the predictors? Can somebody suggest? I'm writing here good practice as far as coding in R is concerned. Kasi I could have used 7 minus 1. No? But anyway, so we can get the N, ano nga lang, medyo matrabaho. Number of columns ni wage. Okay? And I have to put this in parentheses kasi may minus 1 yan. Kasi number of columns ni wage is 8 eh. Diba? 8. 7 lang yung predictors kasi hindi naman kasama si hourly wage, no? So n column of wage minus 1, and then may isa pa tayong minus 1 dito. Minus 1. And then let me close this. Yan, na-close yung denominator. Let me check kung tama itong denominator natin. Control C. Because this is your degree of freedom too, actually. Yan, di ba 518? No? This is your degree of freedom too. Yan. What we could have done also was to do df2 is equal to this one. Para yung formula natin dito, mas simple na lang. Okay, but I leave you to do that, alt minus. All right, so this is our formula, 1 minus R squared times n row minus 1 times the degree of freedom 2. Okay, if we run this, okay, print na natin ADJR2. All right, 36.19 adjusted R squared, which is what we get here, 36.19. Okay. All right. Let me pause for a while. Let me wait for you to chat, please, to confirm that you were able to get this. I mentioned a while ago, another way for us to have done this is to create this object, for example, df2, and this one. So this is n minus k minus 1. And then if we print this, 518, no? And then we can now print natin tong adjusted r squared. 1 minus r squared. This is the formula to get the adjusted r squared times the number of rows minus 1 time divided by degree of freedom. It would look simpler, no? Kasi nakakalito yung formula. No? And if we run this, hindi nag-run tong adjusted R2. All right, 36.9. Okay, so waiting for the others to give their feedback. We had to discuss this class kasi yung regression output, we have to at least know where they were coming from. And we have to it would be good for us to be comfortable explaining what those values are. Notice the adjusted r squared is lower than your r squared. Why? Why is that so? If we keep on adding predictors, okay, if we keep on adding predictors, the r squared will always keep on increasing. However, there's an issue about a parsimonious model. A parsimonious model requires that the lesser the number of predictors, the better. If it's really able to explain your dependent variable. If you can use lesser number of variables, it's so much better because it will be cost-wise and cost-wise in terms of maybe if you're doing a research and if you have to do if you have to gather data for 100 variables, imagine that compared to just gathering data for 5 variables, definitely there will be a difference in terms of cost and of course also the difference in time. So if you're going to make a research, the issue of parsimony comes into play. Is it as far as cost and benefit analysis, is it worthwhile to use 100 predictors, which will be costly and time consuming, as against 5 predictors, when in fact 5 predictors will almost just be the same in the ability to explain the variability of your dependent variable. Okay, so here, what's usually used in determining the explanatory power of your model is your adjusted r squared and not your r squared. Okay, so the adjusted r squared is a formula that penalizes, if you take a look at the formula, it penalizes the use of more variables. Okay, take a look at this. Yung sa denominator natin, ito no? This is our denominator, df2. This one is the number of your predictors, diba? Minus this one. So pag malaki to, what happens? When this is very big, your degree of freedom 2 becomes small, right? And when your degree of freedom is smaller, then what happens to your to this expression? If this is smaller, this one becomes bigger. The whole thing here, this one. Okay, and if this one becomes bigger, then 1 minus that one becomes smaller. So your adjusted r squared becomes less than your r squared. You are penalized for using more predictors. Okay, so as I mentioned a while ago, this is where the concept of parsimony comes into play. All right. So let me pause for a while. May I request class for your chat, for your confirmation if we're clear so far? Are we clear so far? Are there any concerns? Are there any questions? Please feel free to ask questions. Any clarifications about the formula? I would appreciate your response, class, by a yes, if it's clear. Thank you, Mary. Yes, Robbie. Robbie, kindly share your no, your comment to the whole class, please.
Yes, sir. Actually, I was just clarifying what you just said.
Okay.
Yes, sir. I mean, it's really because of you're getting penalized nga.
Yes,
That's
that's correct. That's
adjusted
correct.
R squared smaller.
Yeah.
Thank
Kaya
you, sir.
we do not we do not fall by the we're not, what's the proper term for that? We do not fall to the trap of the more predictors the better. No. No, because you may have 100 predictors, the R squared will be higher definitely compared to a model with only 5 predictors. But we don't look at the R squared. We look at the adjusted R squared. And most probably the adjusted R squared of the model with only 5 predictors will be higher. Okay, because we will be penalizing that model where you have 100 predictors. For all we know, the other predictors are irrelevant. Okay. Of course, automatically the R squared will keep on increasing. Okay, but it will not mean that the model is better. Okay, so we have to take this into consideration. All right, so I hope we're clear so far. Now, going back to the anatomy of our model, okay, I think we have discussed everything here. Okay, from the except for the received values, we're going to discuss that as we go along. Okay, but everything here, the parameters, the meaning of the estimates, okay, the standard error. This one will explain more when we look at the assumptions, the homoscedastic distribution. We focus on the p-value because this is what's needed in order to infer whether a particular variable is a significant predictor or not. All right. Now, okay. We now go to, we will now compare model 1 and model 5, or model 2. Which is better, model 1 or model 2? Model 1 has model 1, which is a simple linear regression, has an R squared equal to 16%. Model 2 has an adjusted R squared equal to 36%. So if we're going to base it on that, definitely model 2 is better because it's able to explain more the variability of your decision of your outcome variable. Okay, in fact, Control Alt I. Okay, let's see the okay, model 1. Is there the R squared here? Wala yata. Okay. No R squared. No? Anyway, so we can test for the, we call it AIC. Capital ba siya? Wait. Or small letter. Kalimutan ko. Okay, so we have this measure called Akaiki. Akaiki information criterion. So what does the Akaiki information criterion, what does it do? It comes from the stats package. So it says here that it's a generic function calculating AIC, Akaiki's information criterion for one or several fitted model objects. So this is fitted model objects, yung regression model natin. Okay, and the format that it uses is ito. We're not going to look at this. Okay, where n par refers to the number of parameters in the fitted model. Okay, so meron ding SBC. Okay, AIC SBC. Okay, so it comes up with a measure And then it tells us, this measure comes from a, hindi na natin kukunin tong ano, no, tong, yung log likelihood model na to. But suffice it to say, class, that the smaller, the bigger the AIC, it means that the bigger is the information lost. No? So this is a measure of information loss. So let's compare the AIC of model 1 and AIC model 2. And let's also do BIC then, di ba? Yung Bayesian Information Criterion. Okay, yan o. Bayesian Information Criterion. They practically measure the same thing. Magkaiba lang yung formula nila. Model 1, comma, semicolon, BIC, model 2. So let's compare them. Okay, let's compare. Model 1 refers to your simple linear regression. Model 2, your multiple linear regression. Okay, as you can see here, model 1 has an AIC of 2777 and model 2 has 2640. Model 2 has a lower AIC, which tells us that this is a better model. So model 2, which has more predictors, okay, is a better model. Also, in terms of BIC, 2790 versus 2679, model 2 is better. So we have looked at two bases to determine whether which model is better, model 1 or model 2. In terms of, so let me write that in terms of R squared, or let's use the adjusted R squared. Model 2 is better. Model 2 greater than model 1. Okay. Therefore, our conclusion is model 2 is better, right? Ba? In terms of our adjusted R squared. Now also in terms of both AIC and BIC. Model 2 is less than model 1 for both. Diba? Thus, model 2 is better. Okay, so that's our conclusion about which is the better model. Okay, however, we are just basing our conclusion based on this metrics, which is acceptable. But is there a statistical test where we can really infer if model 1 is better than model 2? Yes, there is. Okay, and then we'll do that. So we will have ANOVA test, analysis of variance test. We will check which one is the better model. Okay, anyway, in the interest of time, I'll just do ANOVA and let's compare model 1, comma, model 2. All right, before we run this, let me explain what the null hypothesis here is. The null hypothesis is that the restricted model is better than the unrestricted. Okay, so let's answer that question. What is the restricted model? The restricted model is the model that has the less number of predictors. Okay, so pag sinabi natin restricted, it's the model that has the less number of predictors. Therefore, which is the restricted model here? Model 1 or model 2? Class? Which is the restricted model? Is it model 1? Yes.
Model 2 po.
Restricted?
Yes po, sa akin. Kasi multiple po yung regression.
Pero di ba ang restricted is the one with less number of predictors? Sino mas konti, Alvin?
Yung model 1 po pala.
Yes, oh, yeah, okay. Thank you. Tama, no? So si model 1 ang restricted, no? Model 1. Ang unrestricted, model 2. So always, ganun lagi definition, ha? Ang restricted model is the one with the lesser number of variables. I said ang, A-N-G, or the restricted model is the one with more predictors. The unrestricted is the one, sorry, the restricted model is the one with less number of predictors. The unrestricted is the one with more number of predictors. That's always the null hypothesis here. Of course, you can only use this if you have the same dependent variable. Okay, for example, if you can compare hourly wage as the dependent variable and log hourly wage as the dependent variable. That cannot be. No? All right, so let's run this. Okay, let's run this. Control Enter. All right. So here we're don't mind the model 1 and model 2 here. Default lang to ni ano no ni R. In this case, it's correct. Model 1 is the same as our mod 1. Okay, but it does not mean na R was following our nomenclature. Kasi mamaya mag-model 3 tayo. Model 1, model 2 pa rin pagtawag niyo dito. Right, model 1 is your restricted model in this case. Model 2 is your unrestricted model. And then you have here your F statistic, your p-value. Okay, p-value here. Significant at 0.001. So what are we saying here? Do we reject the null hypothesis or do we fail to reject the null hypothesis? Class, do we reject the null hypothesis?
Reject
Yes.
po the null hypothesis.
Yes, correct. Thank you. Thank you. Perfect. No? So we reject the null hypothesis that the restricted model is better. Reject natin to, no? So which means that the unrestricted model is better. So we were able to statistically infer, okay, including based on adjusted R squared, based on AIC, BIC, and based on statistical tests, that the unrestricted model is better than model 2 is better than model 1. Sometimes nagko-conflict to, no? Okay, minsan adjusted R squared might give us a different answer. AIC, BIC might give us a different answer. But we will always refer back to this ANOVA test of variance. All right. So I hope it's clear, class, that indeed model 2 is better. Okay, so what do we do now? Is this now the final model? No, it cannot be the final model because you have here several variables that are insignificant. Apat. 4 variables that are insignificant. Experience is not significant. Race is insignificant. Gender and civil status and number of dependents are insignificant. Okay, so what do? We will perform what we call a stepwise regression. I'll explain stepwise regression more as we go along. But stepwise regression, there are 2 types. There's what we call forward stepwise regression and backward stepwise regression. In this case, we're using what we call a backward stepwise regression. Why is it backward? Because you start with a model that includes all the variables. And then backward tayo, we will be removing the insignificant variables one at a time. So that's what we mean by backward. Stepwise backward regression. Okay, so stepwise because we're doing this regression 1 step at a time. All right, so which will now be the living variable? Kasi we will have to, we do not remove the variables all at the same time. Okay, living variable. We will have to choose one by one. What will be the living variable? That's the variable with the lowest absolute t-value. Okay, so that will be always the basis. You look at the t-values. Okay, let's look at the t-values and we will choose the one with the lowest t-value, absolute. No? So we don't mind the sign. Don't disregard the sign. You say mathematically or algebraically, this might be the lowest, negative 1.556. But we disregard the sign and look at the absolute values. And the lowest is what, class? What variable is the lowest? Definitely, class, hindi natin mapipili dyan, we will not be able to choose there the significant variables because the significant variables will have high p-values. Okay, so which is the lowest absolute value p-value class? Sorry?
NumDep po. Number of
NumDep?
dependent.
NumDep? Baka may mas mababa pa.
Because the absolute value po is 1.3 compare po sa civil status single po 1.5 po yung ano
Pero
niya.
how about the race?
Ay, race weight pala. Ay, race weight po pala. Sorry.
Oh,
sorry.
tama. It's okay, it's okay. It's okay. So, the leading variable will be race, no? Kasi siya yung pinakamababa na t-value, absolute value ng t. So, let's write here, the leading variable is equal to race. Okay? So, race yung talagang variable, ang nagkaroon lang ng white hand because R made it into a dummy variable. So, we're going to remove this. So, let's copy our model. Copy na lang natin para mas mabilis. Okay, this one, Control C. Where are we? Here. Okay, Control V. And let's call this model 3. Let's now call this model 3, and then we're going to remove race. There. Okay, wala na si race, no? Okay, actually, you can also use this here. Then, ima-minus natin dito si race. Okay, so lahat minus race. You can also use that. But let's not bother with that. I just wanted to show you that that can be also. Okay, so let's run this. Summary, ano natin, i-print na natin. Hourly wage, regression, education, experience, new gender, etc. Let's run this. And we have this model. All right. So if you compare, there were changes as far as the estimate is concerned. Okay, were there changes as far as the okay, wala naman change, no? Walang change. All right. But so we now have here, by the way, I forgot to ask a while ago. Sorry. Let me backtrack a bit. Sorry, I forgot to ask you, what's the meaning of this intercept? Okay, this is very important. Huh? Sorry, I forgot to ask you. So what's the meaning of this intercept negative $3.39 approximately? So this is the average wage. And take note, please, we do not put so much physical or pragmatic interpretation to this. Okay, it's part of the model, yes, but the practical or physical interpretation, we do not really put weight to that because this is the hourly wage, average hourly wage. So how can an hourly wage be negative? Negative $3.39 for a person with no education, no experience, no tenure, no number of dependents, who is non-white, who is female, who is married. That's the meaning of this, negative $3.39. Because the intercept is the value, is the average value of your hourly wage of your dependent variable when all your predictors are zero. So zero education, zero experience, zero tenure. Ano ibig sabihin ng zero race? Di non-white, di ba? What's the meaning of zero gender? Di female. What's the meaning of zero civil status? Di married, right? And zero number of dependents. So that's the meaning of the intercept here. Okay, so I hope that's clear, class. Now, what if I ask you, what would be the average hourly wage of a person who has no education, no experience, no tenure, no number of dependents, who is female, who is non-white, who is female, and who is married? Okay, I'll give you a few seconds to figure that out. Again, let me repeat the question. What is the average hourly wage of a person who has no education, no experience, no tenure, no number of dependents, who is married, who is non-white, and who is female. Anyone? What do you think, class? Okay, the answer is
Negative 3.38 po, sir.
negative 3.38. Hindi. The answer
Ah.
is negative 1.63. Bakit? Kasi di ba ang sabi natin, walang education, walang experience, walang tenure. So 0-0 lahat yan, di ba? Tapos no dependence din. So 0 din yan. Married siya. So kung married, 0 to. Ba yun ang
Yes
benchmark
po.
eh. Non-white siya, so 0 din to, di ba? Pero female siya. Sorry. What did I say? Female ba?
Female po kanina.
Ay, naku,
Kaya,
mali.
ina,
Oo, tama. Tama. Kung female siya, 0 din to.
opo.
So mali yung question ko. So, ulitin ko yung question ko. Hindi siya female. So non-white siya, married siya, pero male siya. So kung male siya, class, ang mangyayari, papasok tong 1.759. Isasama dito sa intercept, no? Okay? So ito yung answer. Negative 1.63. Kasi kung male siya, then this will enter the picture, right? Huh? Papasok sa sa pag-compute ng hourly wage. Right? In other words, ganito yun, no? I wish check ko lang check ko kung mag-work tong yung digital pen. Okay. Sana mag-work. Annotate ulit ako. Okay. So our hourly wage is equal to, first is your intercept. This boils down to writing the equation. Negative 3. Let me just round it off. Negative 3.39 plus, ba? 0 years of education kasi beta 1 times education, di ba? So beta 1 is this one, 0.5748. 0 years of education. So i-replace natin to ng 0, di ba? So hindi papasok to sa sa model natin. 0 years of experience then. And in fact, hindi naman siya significant, no? So 0.02194 times experience, but experience is equal to 0. So mawawala yung effect na to. Si tenure, 0 din, sabi natin, no years of tenure. So yung equation niyan, 0.138 times tenure, but tenure is 0, so this will cancel out, right? And then si white naman, non-white siya. So pag non-white kasi, 0 to, di ba? Right? Tapos pag married, 0 din to. Number of dependents, hindi rin significant. So 0 din effect nito. Si male, so what will happen now is, magiging plus, plus, yung beta ni gender male times gender male. Okay. What's the beta of gender male? 1.7. Ba? What's gender male? 1. So 1.7 times 1. So 1.7. It might negative 3.39. The rest are zeros. So it will add up to negative 3.39 plus 1.76. That will give us now negative 1.63. That is the average hourly wage of a person with no education, no experience, no tenure, no number of dependents, who is non-white, who is married, and who is male. Okay? All right. Pa-feedback naman please kung klaro yung ano yan, yung pag-interpret. Okay, thank you. Okay, so let me just clear the drawings. Okay, let's go back here now. All right. So we know how to interpret this. We know how to interpret the intercept. Okay, we know how to interpret education. For every 1 year increase in education, there's a corresponding $57.57 increase in hourly wage ceteris paribus. Okay, ito, male counterparts tend to receive $1.76 more than their female counterparts on the average ceteris paribus. Tenure is also significant. Now there are 3 others that are not significant. What happened to our adjusted R squared? Adjusted R squared increased. Kanina 3619, ito 3631. Okay? And we know the degree of freedom, it's n minus k minus 1. Kasi nabawasan predictors natin, our predictors are now only 6. So n 526 minus 6 minus 1, so that's 519. And for the overall goodness of fit, so it's still significant. H null is equal is beta null is equal to beta 1, beta 2, beta 3 is equal to 0, etc. And we reject that null hypothesis. At least one of the predictors is not equal to 0. Okay? So let's once again test. Copyhin ko na lang to, no? Para mas mabilis. What do I copy? Ano lang. Let's test the Akaike and the Bayesian information criterion, and let's compare. Okay, we're now comparing model 2 and model 3, right? Oops, nangyari. Okay, so I'll replace this by model 2 and model 3. Model 2. So based on adjusted R squared, we know that model 3 is better. Okay, now let's see if it's based on Akaike and Bayesian. Okay, model 2 is 2640, model 3 is 2638. So based on Akaike, model 3 is better. Based on BIC, model 3 is also better. Okay, so it tells us that the additional variable, which is, what did we remove? A race, no? Did not really add to explaining the variable hourly wage. And then we once again, Control Alt I, we do the ANOVA, okay? Mod 2 and mod 3. Now take note again, our null hypothesis, I can't overemphasize this, the restricted model, which is model 3, right? Model 3, because model 3, we remove race. Okay, restricted model is better. Let's see. Let's run this. Okay. So take note class, ito model 1 and model 2 pa rin yung pangalan niya. Okay? Model 1 and model 2. Here the model 1 is the one with race. Okay, the model 2 here is the one without race. And then we have this p-value 0.7971, and the p-value is greater than 0.05, And what's our conclusion? Plus. Which is
The
better?
restricted method is better po.
Why?
Because we accept the null hypothesis po.
Okay, thank you. That's correct. No? I think it's better to say we fail to reject the null hypothesis. Kasi kung tutuusin, we do not really accept the null hypothesis. Kasi we are trying to look for evidence to try to debunk the null hypothesis. Okay, and we were not able to find any evidence. So that does not mean that we proved the null hypothesis. We just failed to reject it. So statistics would usually suggest that we say we fail to reject the null hypothesis and not say we accept the null hypothesis. All right.
Thank you, sir. Thank you.
Okay, thank you. So we fail to reject the null hypothesis that model 3 is better. So model 3 is better. The one without the rays, no? Ito. In this case, yung model 2 dito, no? Yung walang rays. Okay. Command Option O. Okay, so dali lang. May question dito si Robbie. Okay, Rob, can you please share your screen?
Yes, sir. One moment. Kasi parang I was supposed to press command.
Nawala,
option,
ano? Command Option O yung na-press mo.
Pero yung na-press ko accidentally, sir. And I don't know how to...
Sige, tingnan ko nga kung baka nangyayari din sa akin yan.
Parang nabura lahat. Or I don't know.
May lumalabas na ng mga arrows. Sige nga.
Sir, yeah. I'll share my screen, sir.
Sige, please.
Can you see it, sir?
Oo. Ito. Oo. I-control Z mo nga.
Control Z ba?
Subukan mo. Subukan lang natin, ha?
Yeah.
Ayaw ba?
Takot ako mag-press, sir, kasi baka may lumala.
Sige. Actually, that only means that nakatago yung mga ano.
Okay.
I-press mo yung isang orange, yung sa 363, press mo yun. Babalik yan, no? Bumalik na siya, no?
Okay.
Kaso nga lang, may shortcut din yan pag ganyan. There's a shortcut to remove all those eh. Kasi pag i-isa-isa matagal yan. Nakalimutan ko lang kung ano yung shortcut. But you just...
Sige.
But again, Rob, mas mabilis kung may keyboard shortcut din para to revert back to the original. So, explore na lang natin. Ako, I always forget. That happens to me oftentimes. And then I keep on forgetting ano nga ba yung shortcut para mabalik lahat, no? So what you press was command option, or that was Control Shift O, no? Control Shift O.
Sorry about that, sir. Thank you.
No, it's okay. It's okay. In fact, I appreciate that kasi that's also a learning for us. Na if you see that kind of scenario, don't panic. I-click lang yung orange. And there's a shortcut for that. No? Hindi ko lang maalala ngayon, but there is. Okay. Anyway, so let's go back here. So model 3 tayo. No? Model 3 stays. Okay. Model 2 is out of the way. All right. Is the model finished? Not yet. Stepwise regression tayo. No? There are still 3 variables here that are insignificant, and the leaving variable should be, you know the answer there, class? The leaving variable is, what's the leaving variable? Anyone? We will have to remove one variable.
Number of dependents na po, sir.
Yes, correct. Number of dependents already, because experience has 1.7, civil status has 1.5, number of experience 1.33. So we're going to remove number of dependents. Okay, so let's copy our formula here. Copy ko na itong buong ano to. Control C, and then I go down here. Control D. All right, leaving variable is number of dependents na. No? So we're going to remove number of dependents in our model. there, and call this model number 4. Right? O LM, hourly wage, regression, experience, etc. Okay, no more race, no more number of dependents. 2 variables have been removed from our model using stepwise regression, stepwise backward regression. Kasi may stepwise forward regression. Okay. Tapos may stepwise regression lang. So actually tatlo yun, no? Stepwise regression, backward stepwise regression, forward stepwise regression. So what we're experiencing now is what we call a backward stepwise regression, where we first load all the variables and then remove those insignificant ones one at a time. Yung forward naman, baliktad. Forward, you start with nothing and then load one by one. Okay, and then the stepwise regression combination can be forward and can be backward. You can remove and kasi sa backward regression class, once you remove a particular variable, it cannot return. All right, so model 4, let's run this. Okay, and then let's see. All right, if you compare the standard errors, you'll notice that some of these standard errors are going down. Okay, then pero yung adjusted R squared natin went down from 3631, I think. It now became 3621. Right, so it went down, and then here, okay, experience became insignificant. No? Si civil status again insignificant at significant at 10%. All right, so once again, let's check. Okay, I won't anymore explain this class. Okay, I know you know how to interpret those. So let's now compare. Mag-AIC tayo, AIC model model 3 compared with AIC model 4, and then also let's use BIC also, model 3, and then BIC model 4. All right, from R squared, based on adjusted R squared, model 3 is better, right? Because the adjusted R squared of model 3 is greater. It's 36.31. This one, yung adjusted R squared. In this case, it's only 36.21. Okay. All right, so let's run this. Ano nangyari? Ay, sorry.
Capital.
Capital nga pala. I was thinking of a variable. AIC, sorry, BIC. AIC. BIC. All right, let's run this, and we can see here that 2638, 2638, almost close, no? Very close. And model 3 is better here. So dito yung unrestricted model mas maganda. 2638.80. Ito 2638. Wait. Sorry. My mistake. Model 4 is still better in terms of AIC. So we can see here a conflict, no? In terms of R squared, adjusted R squared, model 3 is better because it has the higher R squared. But in terms of information loss, AIC is, in terms of AIC, model 4 is better because it has the lower AIC and the lower BIC, but it's quite close, no? 2638.8 versus 0.6. All right, so based on adjusted R squared, model 3, based on AIC, model 4. But let's, of course, we're going to use ANOVA now. ANOVA. It doesn't matter, class, if I type model 4 first and then model 3. It won't matter. Okay? For as long as you know what is your null hypothesis. So null hypothesis is the restricted model, which is model 4. Is better, having the less number of predictors. Run natin. Okay, and you can see here that p-value is 0.184, which is greater than 0.05. So we fail to reject the null hypothesis that the restricted model is better. So based on this analysis of variance test, model 4, the one with less variables, predictors, it does not have number of dependents, is better than model 3. Okay? So is this the final model? Not yet. We again go back to this
Sir,
one. Yes?
sir, sorry, paulit na ulit yung ano.
Okay, okay. Sige, sige.
Yung sa ano,
Sige.
paano
Dito?
ulit yun, sir? Yung P, di ba, mas better siya
Okay,
kasi
sige. So
stricter than
always,
Q.
always go back to your null hypothesis. Ha? Ito kasi, this is the key. Okay, without understanding this, you'll have difficulty interpreting this. So we're testing always when we're doing comparison of linear models, ANOVA. We're always test the null hypothesis is the restricted model, which is the model with the less number of predictors is better. So model 4 natin is the restricted model because model 4 does not have number of dependents. Di ba tinanggal natin? No? We
Yes,
remove
sir.
number of dependents. So when we run ANOVA, the p-value here is 0.184. Since the p-value is greater than 0.05, then the conclusion is we fail to reject the null hypothesis. If the p-value was less than 0.05, then reject the null hypothesis. If the p-value is greater than 0.05, then we fail to reject the null hypothesis. So since we fail to reject the null hypothesis, then this states the restricted model, model 4, is better than model. Okay.
So balik, sir, hanggat hindi siya nagbe-below 0.05, magko-continue tayo mag-eliminate, sir. Tama ba? Parang
Yeah,
yun.
oo. Kasi, yeah, oo. Kasi si model 4 natin, and until such time na wala na tayong tatanggalin kasi lahat significant na. So,
okay, sige.
di ba model 4 is better? So tingnan natin ngayon, may tatanggalin pa ba tayo sa model 4? May insignificant pa ba? Yes, meron pa, di ba? Yun.
Yes,
We
sir.
have experience and civil status. They're still insignificant, so we can still perform stepwise, backward. So sino yung tatanggalin natin dito? Si experience.
Okay,
That's
sir.
the higher t-value. Okay, did that explain your question? Did that
Yes,
answer
sir.
your question?
Thank you very
Okay.
much.
Okay, thank you. All right, so copyhin ko ulit to, no? Control C, para hindi na tayo mag-type ng marami. Back here, down here, Control V. Leaving variable is now, si ano na to, si experience na. So we're going to remove experience from our model. And, oops, sorry, mali. Control Z. Hindi natanggal. And let's now call this mod 5. Kasi pag hindi ko pinalitan to, ma-override yung mod 4 natin. Okay. Our education, tenure, gender, civil status. So we have here two numerical variables and two factor variables. So run natin. Okay, and we have this model. Okay, now take a look. All the predictors are significant. So as to the question, kung mag-ANOVA tayo later, ano, then we see that it's still, we fail to reject the null hypothesis. We stop already kasi wala na tayong tatanggalin. Di ba? It only tells us that the restricted model is better than the unrestricted. But you notice, class, that the degree of the adjusted R squared also went down. Di ba? From 36, kanina 3631, tapos naging 3620 something, tapos naging 3604 na lang din. So this tells us that the adjusted R squared should not be the main basis of deciding whether a model is better. Diba? Kasi we have to take a look at other parameters. So balikan natin si AIC, model 4, sorry, model 4 versus AIC, model 5. Sige, sama na natin si BIC. BIC, model 4, and BIC, model 5. Okay, let's run. Baka may questions. Rob, ano yung question mo? Sorry.
Well, it's more of like an observation lang, sir. If it's correct ba na parang you mentioned earlier kasi na about R squared being smaller because it means that you're using more predictors. So as we move along, parang ganun din. As we test more of the models, we find out that more predictors are being used. Kaya mas lumiliit yung R squared, sir. I mean, is that
Pero yung
yung
lower R squared, we were actually using less. Okay,
less?
let me clarify that. Kasi
Okay.
dito, yung adjusted R squared natin, 36.04, right? Tapos dito, ang adjusted R squared natin, 36.21. In this model, we had more predictors. Okay? More predictors tayo dito, di ba? 36.21 yung adjusted R squared natin. Dito, less predictors, 36.04. We might be tempted to say that we will choose the model that has the higher adjusted R squared. Because what we know that the adjusted R squared is the proportion of the variability of your dependent variable that can be explained by our model. So theoretically, the higher the adjusted R squared, the better. I'm not talking of the multiple R squared. No? I'm talking of the adjusted R squared. So this is already penalized for adding more variables. So yung 36.21 natin kanina dito, this has already been penalized. If you compare this with the multiple R squared, 36.82 to 36.21 lang. But when we did AIC and BIC, it turns out that mas maganda yung model number 4 kaysa model number 3. And model number 4 has the lower adjusted R squared. So our conclusion there is that we do not use without reservation si adjusted R squared to determine whether two models, which of two models are better. Theoretically, without any consideration for other factors, of course, the higher the adjusted R squared, the better the model is. No? But we took a look at also AIC. This is also a metric used in comparing models. And in this case, when we compared AIC for model number 3 and model number 4, turns out that model number 4 is better in terms of AIC, although model number 4 had the lower adjusted R squared. Okay, so that's a very important point there. So without any clarification at all, adjusted R squared, the higher adjusted R squared, of course, will be the better model. But if we're going to use other parameters like AIC, and of course, a statistical test, the ANOVA, okay, we will be able to really assess which of two models are better. Did that answer your question, Rob?
Yes, sir. Very much po. Thank you.
Sige, thank you. All right, so let's now go here to our AIC, and let's see model 42638. Tingnan nyo to Okay. Now here, based on AIC, model number 4 is better. Okay? Kasi 2638 siya, si model 5, 2639. However, in BIC, okay, BIC, model number 5 is better. So we can now here see conflicts. No? AIC conflicts with BIC, and that happens. No? That happens. So oftentimes when that happens, people tend to use AIC. Kasi may reason din, may reason. But we will not go into that kung bakit mas prefer ng mga tao yung AIC. Although BIC has its strengths. No? Siguro in some future, we will focus on the differences. But medyo lang ako for time ngayon. No? All right, and then what's more important is the ANOVA. Mag-ANOVA tayo. Model 4 versus model 5. Ba? So let's see. And remember, again, go back to the null hypothesis, the restricted model, which is model 5 is better. Kasi si model 5, tinanggal natin yung experience na variable. Okay? So run natin to. Okay. You can see here that the p-value is 0.1198. So we fail to reject this null hypothesis. So model 5 is better based on analysis of variance. Model 5 is better than model 4. Model 5, the one without the experience, diba ito? Ito, wala experience dito, no? Is better than model number 4. Okay, so to the question, should we keep on going? Well, tingnan natin yung model natin. Okay, is there any potential leading variable? Wala na. Wala na. So this now is now our model. No? Ito na yung model natin. Model number 5. So our equation will be, all right, so I wrote here, okay, puntahan natin tong ano, yung scenario ko dito na, ano, na site. Could you kindly look at this site? Kasi it will help you also write your equation. Where is that? Nasa taas yun eh. No? I think it's the start of model 1. I shared with you a okay, where is that? Can see it. I shared with you a site when you're writing the equation for your model. Okay, sige. I think I opened it a while ago. But up here. So let me share this. See? Okay, so this is a very good reference. Let me share this in the chat box. Okay. Okay, can you refer to this and you can let's not do this now, no? You can install this package, and then what this will give you is it will give you the equation in good format para hindi na kayo magle-LaTeX yourself. Remember, this is LaTeX. Okay, so this is the very simple code lang, no? So this is our model, and then extract equation the model. All right, I leave that to you, class, for your perusal. Okay, all right. So let's go back here because I want to discuss some more things. Okay, so our model, we said our final model is model number 5, and the equation for model number 5 is right. Where's that? This is a long document already. This one. Okay, so it's negative 2.16 plus 0.53 times education plus 0.15 times tenure plus 1.7 times gender. Okay. And then negative 0.68 times civil status. The variable actually is gender, no? But we know that it's a dummy variable. Okay, so 1.71 refers to the increment, on the average, male counterparts have $1.71 more in terms of hourly wage than their female counterparts. And all of these are statistically significant. And as we said, the adjusted R squared is 36%, 36.04. Okay, now we do not stop there. Okay, so the next thing that andito pala, no? Ito yata. Yan. Andito yung ano. Andito pala sa ilalim yung site. Okay. Anyway, na-share ko na sa inyo, no? Now, first thing, let's take a look at model 5. Because we can use the plot function of model number 5, and let's see what happens. If I run this, you notice that there are four plots here. So this is the fourth plot. This is the first plot. If I just want the first plot, I put here 1. Okay, so plot model 5, number 1, it will give me this one, the residuals versus fitted. So let's run that. Okay. Ito yan, no? This is the first plot here. So you can see here, this is the plot of the residuals and y-hat. And this will tell us about the behavior or distribution of your residuals. And you can see here that it seems to be heteroscedastic, no? Hindi equal yung, hindi constant yung variance. As you increase the fitted values, tumataas yung residuals natin. Okay, so this is a visual indication that we are violating for this model the homoscedasticity assumptions. Okay, and then let me plot model 5. How about the second one? What will this second one give us? Okay, ito yung QQ plot, quantile plot, normal QQ plot. So this is to test the normality of the residuals. So if the residuals are hover around this regression line, okay, yung residuals natin, yung standardized residuals are close to this one, then it tells us that the residuals are normally distributed. Now you can see here numbers 229, 59, and 15. So these are respondents. These are the number of your observations that tell us that they are outliers. So malayo siya dito sa line na to, sa diagonal na to, yung QQ line natin. All right, and then if I, let's see, plot natin si model 5, number 3. What do we see here? This is the third plot. And then we can also see here, scale location, residuals din to, and then the fitted value. So standardized nga lang siya. A while ago, residuals versus fitted value. Here, standardized residuals versus fitted value. Now, importante to kasi it will indicate to us outliers and possible influential points. Influential points are very important when you're analyzing your data, your model, because these influential points has the effect of changing the values of your coefficients dramatically when they're removed. Their presence really changes the parameters. Okay, we're not saying now that influential points na to, itetest pa yun kung influential points ba yan. But be aware of the presence of influential points. So tingnan natin si Control C, Control V. How about the fourth? Ano binibigay sa atin ni fourth? Okay. So binibigay dito si Cook's distance, no? Cook's distance is used in determining kung ang isang data point is influential. So dito consistent, no? Dito si 112.59 at 260. So based on Cook's distance, the observation number, okay, Cook's distance. So it tells us that these are possible influential points. Iba yung influential point sa outlier. Not all outliers are influential points, but all influential points are outliers. I hope you get that. Not all outliers are influential points, but all influential points are outliers. Okay, and lastly, meron nga hindi nga pinapakita dun. Pero there's actually a fifth plot, no? Uy, wala na. Oh. Ay, sorry. Mali pala ako. Mod 5.
Sir, I'm sorry po. Ano po ulit yung Cook's distance po?
Cook's distance. Okay, Cook's distance measures whether a point is influential or not. No?
Okay po.
So itong Cook's
Sige po.
distance, may benchmark na ginagamit yan. Explain natin when we go deeper into diagnostics. We're not actually going deep into diagnostics now. No? Pinapakita ko lang na ito yung gagawin natin. na after our model, kailangan tingnan natin kasi paano kung violate yung assumptions? Anong gagawin natin kung homoscedastic, kung heteroscedastic? We said that if the model is, if the residuals are heteroscedastic, then our model ceases to become blue. No? Hindi na siya yung best linear unbiased estimator. Lu na siya, Lu. Linear unbiased estimators, pero hindi na best. So we have to address that, and there are several ways to address the non-constant variance ng mga residuals. All right. So meron pa rin tayong yung 5, ano? All right. Ito naman residuals versus leverage. So si leverage class, ibang ano naman yun, ibang measurement naman yun. Related siya kay ano, kay influence at saka kay outlier. Pero ang pinaka critical si influence points. Okay, dito na identify din yung mga leverage points. 260, 59. Kasi itong mga leverage points, it tells us that this inflates your variance. So lumalaki yung variance. And sinabi, 'di ba, pag lumalaki yung variance, hindi na nagiging homoscedastic yung ano natin. So nakaka-affect ng 3 points na to. And consistent sila. Dun sa influence points, lumabas sila. Sa outlier, lumabas sila. Sa leverage, lumabas sila. Okay? Now, take note, pag lumabas sa influence points yan, lalabas yan sa outlier at saka sa leverage. Pero pag lumabas sa outlier, okay, pag lumabas sa outlier, not necessarily na lalabas siya sa influential points. Because not all outliers are influence points. But all influence points are outliers. Now, if we want to plot this together, no, kasi isa-isa siya eh. I-partition natin. So we have this function par, which is partition. The number of rows is equal to, gawin natin 2 by 2. Okay? 2 rows, 2 columns. And then, saka natin i-plot si mod 5. Okay. So if we run this together, okay, it will generate, ito kasi isa-isa lang, di ba? Ito, together sila. Kaso ang inaano lang nito yung 4 lang. Hindi niya generate yung ano eh. Yung itong pang fifth, yung residuals versus leverage. I don't know why. No? I've tried making this 3, 2, 2, 3, 3, 3, etc. Hindi pa rin generate. Okay. All right. So we have here, yan. Okay. So nasa isang ano na siya, no? Nasa isang plot na. Yung 4 kanina, no? If I make this 2 rows and 3 columns, let's see. Run natin to. All right. So yung 4 lang din ang inaano niya, print, no? Yung 4, hindi niya print kanina yung ano, yung sa leverage points. Wait. Residuals fitted, normal QQ. Nawala yung cooks, Nawala yung number 4. Nawala yung number 4. 2, 3. If I type 2, 2 lang, 2, 3, tinanggal niya yung pang ano, no? Okay, let me see this. Okay, 4. So, nawala si cooks. About this. Ito yung 4 kanina. No? So, ito yung nawala, cooks distance. Okay, yung number 4. If I try to plot them together, hindi sinasama si number 4. No? Yun lang na-observe ko. I've tried doing this several times already. Tapos wala. Hindi niya sinasama si ano eh. And I haven't discovered the reason why. Hindi niya sinasama yung Cook's distance dito sa pag-plot ng mga diagnostics natin. Okay, of course, class, there are statistical tests para matest natin yung ano, yung heteroscedasticity or yung normality of the residuals. All right. Okay, we still have some more minutes. Now, this time, kasi ang ginawa natin, nag-manual tayo, di ba? We did manual for the stepwise. Okay, we're going to make use of a package. So, paki-install to, o pacman na lang. No? Pacman, para mas mabilis. Pacman pload. And then OLSRR. Oops. So, we're going to load OLSRR. Okay. Paki-load siya class. And then let's do some ano here. Dito na lang sa packages. When it's loaded, open it here in the view window, OLSRR. Let's just take a look at what this will give us. So it's tools for building OLS regression model. Ordinary least squares regression. I think this is in R. Huh? Okay. If you're done, please kindly chat so that I know when to continue. Thank you, Rob. Okay, let me load it also. Although naka-load na siya, no? And so what is this package for? Tools for building OLS regression. If I click this, all right, so description file niya. Okay, tools for building regression model, ang current version 0.5.3. Authors, Aravind, Hebali, Aravind. So what's this for? Tools designed to make it easier for users, particularly beginner, intermediate, to build OLS, regression tables, includes comprehensive regression output, heteroscedasticity test, collinearity diagnostics, residual diagnostics. So halos andito na lahat, class. Yung kakailanganin natin, no? It's already here. Plus, we're going to look at other packages also. But let's try this. So let's have our first try of OLSRR. Okay, sabi natin, di ba kanina, there are 3 types of stepwise regression. You have the stepwise regression lang, you have backward, and you have forward. Okay, so let's create a model. Let's call it model 10 na lang. No? Let's identify this model, and it's a linear model, LM. Okay, let me just do the shortcut. Hourly wage regressed on that data. Okay. So we're creating this model. Ito yung parang model 2 natin kanina. No? But let me just use a new name for it. Model 10, which is LM. Okay, actually, pwedeng model 1. Ba? And then model 1 is simple. So ito na lang, model 10 na lang. So let me run this. All right, we now have our model 10. No? And then what I'm going to do now is I'm going to make use of COLSRR. Control-Alt-I. OLSRR. So that's a package. And then, ito yung mga, ano sa kanya, ito yung mga functions. Yan, hanapin natin, ito, tinan nyo, class. OLS. OLS. Yan. So many functions. Tayo na lang magsasawa kung ano yung ano. OLS and then step. Hanapin natin si, type ko na nga, OLS underscore para mas mabilis. S. R. Yan, class. Step. No? Ang ginamit natin kanina, step backward, di ba? Right? So let's do this, step backward. And then there are 2 methods here for step backward. Pwedeng step backward na using AIC. Ibig sabihin nito, ang gagamitin niya na base is AIC. The lower the AIC, yun ang papasok sa model. Ang ginamit natin itong P. Right, class? Di ba? P ang ginamit natin. We looked at the P value, the T-stat, tapos kung siya yung pinakamaliit na T-stat absolute value, tinanggal natin siya. Yung mga hindi significant, no? Tinanggal natin. So let's run that. Yan. And then use model 10. Di ba si model 10, yung complete model to. So we're now using OLS step backward using P as the basis, P values for model 10. Let's run this. Okay. Okay, hindi yata, wait ha, hindi kompleto. Ano yung 10 ko? Hourly wage, regression, all the variables. Ang kulang ba yung model ko? Okay, this should give us, but isa lang na-eliminate. Okay, let me check lang siya. Kasi dapat ipapakita, it should show all the variables that race lang yung remove, no? Okay. Remove race lang, wait ha. So, ano mali sa model natin? Dapat, ano, wait ha. Okay, let me OLS step backward P. Ito yun eh, no? Build regression model from a set of candidate predictors by removing predictors used based on P values in a stepwise manner, no? Until there is no variable left to remove anymore. Ito yung ginagawa niya. Okay, pero okay, sige. Let me see. Punta tayo sa ano, sa help natin dito. Let me see the syntax. Ito, OLS step backward. Yan. Let's see this. So OLS step backward P model, P remaining details is equal to false. So siguro kulang ako ng details is equal to true. Let me check. Okay. And then details is equal to true. Sige nga, let's try this, class. Tagal ko na kasi hindi nagamit ng OLSRR. Yan, ayun. Okay. So ito na, no? Pinakita na niya yung whole process na ginawa natin, class. Okay. So let's wait. It's still running. Okay, this is what the OLSRR package does. Kung ano yung ginawa natin, whatever we did a while ago, one step at a time, it now generated this answer. So backward elimination, ito yung original natin, di ba? Pag backward elimination, you start with the whole model. And then the first one is to eliminate race. Di ba? Right? We are eliminating variables based on p-value. Isn't this the first, di ba ito yung unang variable na eliminate natin? Backward elimination step 1. So what happens when race is removed? Okay, ito ngayon yung adjusted R squared. Okay, remember this 36.30 something. These are measures. This is now Ramsey root mean square error, measure of error. Ito mga measures ng error to, mean square error and mean absolute error. Okay, and then you now have your ANOVA, and significant, ibig sabihin, our null hypothesis is that all the predictors are equal to 0. And then we have here the parameter estimates. Okay, nung tinanggal natin si yung si race, ito yung naging ano, ito yung naging result. So this is the model 3, no? Na ginawa natin, tinanggal natin si race. Okay? All right. Then susunod ay wait. Sandali I think nag-default siya sa okay. Bakit naging 0.3 yung ano niya? P remaining. So bakit siya nag-default ng P remaining? Okay. Let's add that, class. Sorry about that. Nalito na ako sa dami ng outputs natin. P remaining should be 0.05. Okay? So dapat yung P para ma-maintain siya, dapat less than 0.05, no? Yung P. So let's do this. Let's run this again. Okay. Kaya pala nag-ano kanina, class, kaya pala raise lang yung dinelete niya is because nag-default siya sa 0.3. I wonder why 0.3 yung ginawa ng default dito. Okay, so here we defined our P remaining should be 0.05. So a variable will enter the picture if and only if, time na pala, no? So let me just finish this class. No? If and only if the P value is less than 0.05. So take a look at this. Eliminate race. No? Okay, once race is eliminated, nagbigay siya ng metrics. Okay? And then next na in-eliminate na number of dependents. So that's backward elimination step 2. So once again, may mga model summary siya, may ANOVA, and the parameter estimates. So this is the same as what we got a while ago. And then experience naman, in-eliminate niya, stepwise number 3. Okay? And then yun ulit. And then no more variables satisfy the condition of p-value is equal to 0.05. Okay? So this is what we did a while ago, diba? We manually removed yung race, yung number of dependents, yung experience. Okay, and then it gives us the final model here. Hindi na nagkasya. Okay, so it summarizes what were the variables that were eliminated, no? Race. Tapos ibibigay niya sa atin yung measure ng R squared. Okay, adjusted R squared. So here, you can see that even if the adjusted R squared it was going down, pag nag-eliminate tayo, still, ito pa rin yung better model. And then this is Mallow's CP, which we're going to discuss next time na lang, AIC, and the root mean square error. And this was your final model. Ayan. Beta, these were the parameters, standard error, p-value, okay, p-values niya, okay, and then the lower and the upper confidence interval value levels, okay? So you notice that dito sa, between the upper and the lower, you will not touch 0. Hindi gigitna si 0 dito sa values na to. Ito pa rin negative, so not possible for 0 to be touched in this range. Okay, kaya significant sila. Hindi kasi possible na magka-values ang 0 dito. All right. So it's time, class. So let me stop recording. Next meeting, we're going to continue with this.